Hello, this is Kona, and I'm going to talk through 11.2b just because, once again, I think this one could be a little bit confusing. So, first thing you do, go ahead and get your null and alternative. You can set up the fact that it is two-tailed because we're saying there is no difference. Because it's two-tailed, you remember you need to take half of alpha. Then the other thing, because you are using your z table, the standard normal table, you actually have to do 1 minus half of alpha. So that 0.975 is actually the number you're going to be looking up in the middle of the table and work your way out to get that critical value of your plus or minus 1.96. And remember, that's just because it's two-tailed, so you've got your two different rejection regions. Okay, so now for the really fun, confusing part. How do you actually set this sucker up? Well, I will be really honest. This was not real fun to do by hand. You could do it by hand, and maybe this one's probably easier to do by hand than the other one. But for me, I went ahead and I entered all of this into an Excel spreadsheet again. And I just went ahead and entered, 51, 59, 52, 46 going down. And then I put Wisconsin for all of those, and then I did Michigan, so that way it was all in the same line. I then went ahead and just ordered it from least to greatest. So you want it from least to greatest. And so that's where you kind of get the mishmash of, a 46 is Wisconsin, a 49 is Michigan, a 50 is Wisconsin, a 50 Wisconsin, 51, but then you run into some more Michigans. So the biggest thing, though, is that you want to get all of your data. They're not going to be side by side. In this case, they're going to be one long row. And for that one long row, you want to make sure you keep which sample the number goes with. So make sure you've got your data organized from least all the way to greatest with where the sample came from. Then you go to the rank. The rank is going to be similar to what we did in the previous problem, where you literally go to the first one, and that's number 1, second one's number 2. Okay, so now we're at 3, and 3 and 4 are the same number. So what we do, we add 3 and 4, divide by 2 to get 3.5. So now, because we used up 3 and 4, those ranks, we come down to Wisconsin 51, Wisconsin 51, Wisconsin 51. We get those 3, and what we need to do is use up 5, 6, 7. And then we have a Michigan 51. Sorry, but so we've got 5 or 4. I'm sorry, that are all 51s, and so that's going to basically use up our 5th, 6th, 7th, and 8th rank. So we just add 5, 6, 7, 8, divide by 4 to get our 6.5, 6.5, 6.5, 6.5 for all of those. So at this point, you might think, well, this seems weird. We're jumping from 6.5 to 9, but that's just because we've used up the 5, 6, 7, and 8 rank. So the next rank is that 9. We then come down to Wisconsin, Michigan here for 53. So that would be our 10th and 11th rank, and we need the average, so add, divide by 2. Then because we used the 10 and 11 rank, the next rank is 12th. And you can just see kind of how we work our way down. 13, 14, 15, 16, 17, 18, 19, 20, 21. That's where you're 20.5. Then 22 and 23. Whew, okay, yeah, everyone's still with me? Very good. All right, so the next thing, we're going to come back over here to number 4, and I guess we could have done 4 before 5, so I apologize. Whichever. Here we're doing, looking at N1 versus N2, and our N1 is less than 12, and so basically this is just kind of a check to make sure that this is less than or equal to make sure we can do these, and it is less than or equal to, so we were good to go. So technically I should have done that before this, but well, sorry. Moving on to number 6. So because R is the smaller sample, what we need to do is find the sum of Wisconsin. Or for R, what we do is find the sum of Wisconsin, which is the smaller sample. So Wisconsin, we take all of these ranks. So you can see we've got the 1, the 3.5, 3.5, 6.5, oh, you know what I just realized? I'm missing a 3.5. R. Okay, so ignore the missing 3.5 that I didn't write in there, but I promise that that R is the correct R. But I just realized that, oh no, maybe I'm not. Oh, ignore me, ignore me. Sorry, it's been a long day. It's my Friday, technically. So it's been a long day. Ignore me. This is exactly correct. I added up all of my Wisconsins. I got 100.5. I then find mu of r, which is r. This is where your n's come in, your n1 and n2. And this is basically just, I took the formula for mu of r and plugged in my n1 and n2 to get 264 over 2, which is your 132. I then took our variance of r, so square root. This is just the formula. Once again, all of those numbers are coming from n1 and 2 to get our 16.248. So then, finally, we're down to our z. We take z is equal to, then we do our 100.5, and that's that r that we found where we took the sum of all of the Wisconsin ranks right there. Subtract our 132, which was our mu, divide, and by our 16.248, we get negative 1.9387, which when you round just equals negative 1.94. Now if we take that all the way back up into here, look at where negative 1.94, now it's right there on the edge. It's almost in that reject region, but it's not. So we are able to fail to reject this hypothesis. So our interpretation, there is not enough evidence to support the claim that there is a difference in the salaries earned by teachers in Wisconsin and Michigan. So I hope this helps, and if you have any questions, please let me know.